Good morning, students. Right now we will discuss about addition, subtraction, multiplication and division rule of errors. So first of all, you can just say that addition and subtraction of errors. In a previous clip we have discussed about there are a number of observations we have taken and what type of error we have observed. So we have observed addition, we have observed its average, absolute average, then comparison, relative and percentage average. So in this clip we will discuss about the additional error. So very first rule is called as our additional rule. In this additional rule, first of all, let's say I'm just observing that I have one observation x equals to a plus b. So you can just say that my a is one observation and b is another observation. Let's say I'm just mentioning that first of all delta a is called as error in observation of a, or you can just say that that is called as absolute error in small a. Delta b is called as error in observation of b, or you can say that it is called as absolute error in a small b. So these are the primitive notations I have mentioned. First of all, delta x. So as per our notation I can just say that error in total or net observation, which is called as x, or you can general mention that error in x. So first of all what I am doing is that mentioning that x plus or minus x. Always remember that very first one is always our real observation and next one is called as absolute, or you can say that error part. So these are always notated part, x plus or minus delta x. So first of all a plus or minus delta a plus b plus or minus delta b. So these are the things we have to mention, that error in a and error in a b. So right now just I am arranging these terms. X plus or minus delta x is equals to, I am opening this bracket for you, a plus or minus delta a and b plus or minus delta b. So what we have observed over here is that arranging these terms will make get that x plus or minus delta x, a plus b plus or minus delta a and plus or minus delta b. You can see that from the very first observation we have mentioned that x equals to a plus b. So we may get over this value and we are placing this value, equation number 1 is been placed in expression number 2. So we may get x plus or minus delta x equals to x plus or minus delta and plus or minus delta b. So delta x can be cancelled out from the both those parts. Delta x equals to plus or minus delta a and plus or minus delta b, bringing it out delta x and plus or minus common. So we may get that error in the total net will be the sum of the both the observations x means delta a and delta b. Now what we are just discussing about is that very first example for that, so you may get a better idea. Let's say we have very first part is called as our capacitor. So there is a capacitor is new thing for you. Let's say I have two observations. C1 is called as a 1.3 plus or minus zero point 0.1 microfarad, and then value of a C2 that is called as a 2.4 plus or minus zero point 0.2 microfarads. I want to find it out error in parallel combination of capacitors, and from that I am just finding it out percentile error. So first of all what I am doing is that bringing that data formula of a CP. It is donated as a parallel combinations of capacitors. So what I'm mentioning is that CP's equation is called as a C1 plus C2. It is the same equation which is actually replica of our parallel combination and series combinations of resistors. It is vice versa. For the capacitor it is called as a parallel, and for the resistance it is called as a series equation. So I'm doing is that addition of both those things. First of all, I'm just putting that actual data. So our actual data for the C1 is 1.3, and for the C2 it is 2.4, so I may get that 3.7. Its unit is, first of all I'm mentioning that CP, it is the data for the real one. I get that 3.7 microfarads. As per my notation, I have discussed to you that is delta x is called as the sum of the both this error part, or you can say that both are sum of the absolute errors. So I may mention that delta CP is called as plus or minus delta C1 plus or minus delta C2. Rather than placing that plus or minus both these times, you can mention the delta C1 plus delta C2. So I may have plus or minus delta C1, that is called as a 0.1, and delta C2 is called as a 0.2. So you can just see over here, that is called as a delta C1 and delta C2. In secondary you may have learned that there are the representation of data in the words and mathematical nomenclature. The same is the course you will follow over here, that is called as a zero point 0.3 microfarads. So this is the value we got that for the delta CP. I want to mention in terms of our relative, or then we have percentile. So I'm mentioning that plus or minus delta CP divided by CP multiply by 100%. Delta CP I got is called as a zero point 0.3, and for the CP it is called as a 3.7 multiply by 100%. So I can get percentile error for my capacitor equals to plus or minus 8.1 percentage. You can show this data in the terms of a real and error part. You may mention CP plus or minus delta CP. CP part is called as a 3.7, and delta CP is called as a 0.3 microfarads. So this is the thing. You can say that your addition of both the capacitors contains a real value 3.7, while the fractional or error part contains 0.3, while the percentage is 8.1. So after this addition rule, we may just shift to the another part, that is called as our second rule, which is called as subtraction rule. So that is called as subtraction of errors. For the subtraction of errors, first of all we will just mention that x equals to a minus b or b minus a. It is up to you whichever part you want to follow as per our notations. You are aware about now delta a and delta b. So delta a and delta b are called as ace error or error in a. And delta b is called as a error in the part of b. You can just also mention that absolute error in a, small a, and this one contains that absolute error in small b. So these are the delta and delta b's where you can mention your errors. You are also aware about delta x is called as your absolute error in the terms of x, or you can say that error in x. So this is how we are representing it, our errors. So as per our rules and regulation, I'm mentioning that x plus or minus delta x equals to a plus or minus delta a minus b plus or minus delta b. Arranging these terms for you may give me answer a minus b plus or minus delta a plus or minus delta b. So you can see that from equation number 1 we have x equals to a minus b. So equating this value of 1 into 2 may leads to x plus or minus delta x plus or minus delta a plus or minus delta b. X can be cancelled out from the both these sides. We may get plus or minus delta x equals to plus or minus delta a and plus or minus delta b. Bringing it out plus or minus common from both these sides, I may have delta a plus delta b. This is nothing a new formula, which is same as we have learned for the additional part. If you can just see that in the addition rule we have mentioned the same formula. It is called as delta x equals to plus or minus delta a. Yes, in addition and subtraction, wherever we have a plus or minus, we are adding them together. So you can say that delta x is called as nets or sum total, or sum of error, is a combination of both the observations error. So this may lead to your actual part, okay, where our error is playing its a part. Let's say we are solving one example for you. Let's say I have one data dealing with subtraction. I have length part. Very first length I have is called as 5.62 plus or minus 0.01 centimeter. This is 5, and L2 equals to 4.34 plus or minus 0.02 centimeters. I want to find it out difference between the lengths. So what we are doing is that mentioning that normally L2 minus L1 is called as L. So I am just placing their value. L2 equals to 4.34 minus 5.62. In the real part you can go for the addition or maybe go for the multiplication or subtraction, but in an error part there is only one rule, that we are only adding them together. So we may have L equals to minus 1.28 centimeter. This is called as a real subtraction. Now what we are doing is that delta L is called as a delta L2 plus or minus plus delta 1, because as per our subtraction or addition rule we are always adding them together. Plus or minus delta L2 is called as a 0.02 plus 0.01, that is called as a centimeters. So I can have delta L is equals to plus or minus 0.03 centimeters. Only simple way to represent that in the terms of a real and our absolute error part, L plus or minus delta L is equals to minus 1.28 plus or minus 0.03 centimeters. This is how we are calibrating our subtraction part. Always remember, whenever you are dealing with your real observation, there might be positive or negative sign may conclude, but whenever you are dealing with the error part, it may contain positive or negative part, and that is the area where we are not or lesser bother about. Now third part is called as our multiplication rule. And this multiplication rule is nothing new for us. It is like a normal multiplication we are doing, but only the thing part we are just carried about is called as its error part. So first of all I am putting that x equals to a cross b, or multiplication of a cross b, a and b. Now error part, you are aware about delta x is called as error in x. Then we have a delta a, which leads to the error in a small a. Then we have a delta b, which is called as error in a small b. So same course I am following, that x plus or minus delta x. So my x plus or minus delta x equals to a plus or minus delta a multiply by b plus or minus delta b. And usually what we are doing is that general mathematics we are applying it. So there are two options we have, both I am putting in front of you. X plus or minus delta x multiplication of ab plus or minus a delta b plus or minus b delta a, and plus or minus delta a and delta b. It means that I have multiplied first term with the both and second term with the both. Or you can just say that simply I am just bringing out x common from this segment. It may lead to 1 plus or minus delta x by x, and from this bracket I am bringing it out a common. So 1 plus or minus delta a by a in multiplication b 1 plus or minus delta b by b. You are aware about that normal mathematics, that in multiplication we can shift those parts, 1 plus or minus delta a by a and 1 plus or minus delta b by b, and that may lead to x delta x by x. This would be expression number second. So one place in the expression number second may give me x equals to ab. That might be cancelled out. So left part is 1 plus or minus delta x by x equals to 1 plus or minus delta a by a and 1 plus or minus delta b by b. And now multiplication may happen. That is why we have a 1 plus or minus delta a by a plus or minus delta b by b plus or minus delta a by a and delta b by b. Wherever delta a and delta b contains the denominator a and b, actually we can just say that delta a by a is very much lesser than 1 and delta b by b is also very much lesser than 1. So last term, which is smaller than 1, can be neglected. So left part with us is 1 plus or minus delta x by x, 1 plus or minus delta a by a and plus or minus delta b by b. So we may get plus or minus delta x by x plus or minus delta a by a and plus or minus delta b by b. So we may get only plus or minus common, delta a by a plus delta b by b, which is the equation which may give me that whenever we have a and b, both can be added together. So there is only some difference in a subtraction and addition. In a subtraction part and addition part, we don't have that a and b in denominator, while in a multiplication and division we may have that delta a by a and delta b by b in the denominator part. So we are just going further and discussing about if one formula or equation for the area part. Let's say I'm just putting one expression for you. Let's say one example for a rectangle. For one rectangle, my length is given to me. It is 2.3 plus or minus 0.2 centimeters, and the breadth given to me is a 1.6 plus or minus 0.1 centimeter. I want to find it out area or error in area. So I want to just calculate L and B and area, and I want to just find it out error in this part. So first of all, I am putting that expression L cross B. This is real L, this is the real B. So I may have 2.3 multiplied by 1.6 centimeters square. So area I have is 3.68 centimeters square. This is the first expression I may receive. Next one is that I want to find it out delta A, but my equation is suggesting me that go for the delta A by A because it is the equation. So I am first of all using that delta A by A. So I may have plus or minus delta small a by A plus delta B by B. So I may have only delta A by A is equals to plus or minus delta A is 0.2 divided by 2.3 plus, because this is delta A and this is delta L by L and this is delta B by B. So I am putting that plus or minus delta L by L and delta B by B. So I have 0.1 divided by 1.6 delta A by A is equals to plus or minus, I have data ready to me, that is called as a 0.55. After that LCM and addition 3.68. But I want to find it out delta A. So delta A equals to plus or minus 0.55 that divide by 3.68 multiply by A, because I have just taken that A from this cross multiplication. So I may have delta A equals to plus or minus 0.55 divided by 3.68 again multiply by a, which is a 3.68. You can see over here. So I got that delta a equals to plus or minus 0.55 centimeter square. I want to just show in the terms of our description manner. Delta a is equals to a is a 3.68 plus or minus 0.55 centimeter square. This is how you can calculate your multiplication rule. So now we want to just move to the another part, that is called as our divisional rule. Divisional rule is somehow, you can say that, same rule as our multiplication, but its method is somehow tricky. Not actually tricky. If you are fan of maths, then you will love it. It is called as our divisional rule. So I have mentioned that x equals to a by b. Now you are familiar with delta x and delta b notation, so I'm mentioning that directly. Delta x, a plus or minus delta a divided by b plus or minus delta b. So I may have x plus or minus delta x. A is common, 1 plus or minus delta a by a, and b 1 plus or minus delta b by b. Let's say equation number 1 contains a by b. A by b and x can be cancelled out. So I may have a plus or minus delta x equals to 1 plus or minus delta a by a divided by 1 plus or minus delta b by b. For our simplicity, we can also mention that it is called as a double implies 1 plus or minus delta a by a and 1 plus or minus delta b by b raised to minus 1. But I want to just remove this inverse symbol. So what I am doing is that by taking the replica inverse of delta b by b, but we have plus or minus sign already available to us, so I'm utilizing it. So you can see that here I have mentioned plus upon minus, and I have minus or plus delta b by b. It also represents the same notations. So now it is having multiplication rule, as we have discussed previously. In a multiplication rule, 1 plus or minus delta a by a minus plus delta b by b plus or minus delta a by a and delta b by b. As per our rules notation, we are aware that delta a by a is very less than 1. Same is the course for delta b by b is very much less than 1. So we are neglecting this last term, and we may get that plus or minus delta x is equals to plus or minus delta a by a plus or minus delta b by b. So we may arrange these terms and mention that plus or minus delta x plus or minus delta a by a plus delta b by b. So this is the same course as we have just discussed about in our multiplication rule, that it is called as a sum of our observations error, and it is called as a sum of absolute errors is equals to net sum. So this is the rule which which is called as our divisional rule. Now last not least is very important one, and maybe asked in so many exams, or maybe so many competitive exams, some of the relative examples based to it. So it is called as our power of errors, or errors containing power. So we are utilizing it, mentioning that x equals to a to the power n and b to the power m. So this is my first equation. Let's say my a is observation, contains n power, and b is also my observation, contains m power. So I'm just taking my observation, and let's say I'm just saying that taking log on both sides. So I can have a log of x equals to log of a to the power n and b to the power m. So I may have log of x is equals to log of a to the power n minus log of b to the power m. But as per our notation, log of x is called as n log a minus n log b. But in future you will be aware that it is called as a log notation. Dx by x is called as a log x. Same is the course. Instead of dx you can place that delta x by x is called as a log x. Delta a upon a is called as a log a, and delta b by b is called as a log b. So we are putting these values. In differentiation you will learn such about of powers. So we have delta x by x is equals to n times log of a minus m times log of b. But we have to place delta x by x, so I can have plus or minus n times delta x by plus or minus n times delta a by a, and then we have plus or minus m times delta b by b. As per our rule we are putting plus or minus outside, so I can have n times delta a by a plus m times delta b by b. So this is called as error in the powers, and error contains powers. So delta x by x, this is the same rule which have no difference compared to our previous rules. Only the difference is that whichever power it has, that power is going and coming in the multiplication. Remaining rule is following our multiplication property. So I'm just putting one example for you. It may clear your all datas, and later some of the clips we will mention some of the good examples which may clear your all those doubts related with the error part. Let's say I have one data. I have one equation, g is equals to 4 pi square l divided by t square, and my errors in length l is 2%, and my error in a time is equals to 3%. Whenever percentage data is given to you, indirectly you have to just consider that they are dealing with the delta L by L multiply by 100%. Directly they are mentioning you 2%. Delta T by T multiply by 100% will directly given you the data that is called as a 3%. So now we are just switching to our data. G is equals to 4 pi square L divided by T square. Whenever you are calculating such type of data or power or addition subtraction rule, we are not at all in position to include such type of constants. That pi contains constant part, it does not contain any type of error. Numbers does not contain any type of error. So we are neglecting whenever we are calculating such type of calculation for the error part. So now we have a left part is called as a g is equals to L divided by T square. So as per our notation, I am mentioning that delta L by L plus 2 times delta T by T, and here plus or minus, and I have data in the terms of percentages. So plus or minus is there. Our power rule has been there, that is called as a power is 2, that is why 2 multiply by delta L by L is ready, that is called as a 2 percentages, and 2 multiply by delta T by T is also ready, that is called as a 3%. So I can have a plus or minus, that is called as 8%. It means that my data is called as a delta G by G. In the terms of percentage, you can mention that error in measurement of G, which is called as a gravitational acceleration, is equals to plus or minus 8%. It It means that error can be positive or negative, and that may be in the terms of a percentage or fractional or real part. So you might be aware about some of the basic primary rules of addition, subtraction, division, and multiplication, and in the next clip we will discuss about some of the very good examples related with the all our rules, 5 rules: addition, subtraction, multiplication, division, and power rule, so it may clear all your queries. Thank you.